Alright, so homework problems. We are looking at 3 problems on this second video. We're going to start with number 9 from the website. Alright, so looking at this, I see cosine of something is my given f of x. And the stuff is 5x squared. So the second derivative is this. The outermost shell's derivative is what? Negative sine. And it's negative sine of what?
5x squared.
5x squared. Remember, that was the cream that was untouched. Thank you. And then you multiply by the derivative of the inside, which is what? 10x. And my suggestion to you always is to try to simplify as much as you can before you keep going, okay? Otherwise, it can be very, very daunting of what you're looking at. So I have negative 10x sine of 5x squared. And I want the second derivative. And looking at the second derivative, the power of parentheses tells me this is going to be a product rule. So the second derivative, make sure that you guys are writing these very, very correctly as you go through the problem. And you'll see why as you do more homework. Okay? So it would be the first times the derivative of the second. And what's the derivative of the second? Cosine 5x squared. Keep going. Times 10x. We good? So first times the derivative of the second plus the second, oops, it's a sine, times the derivative of the first, which is what? Negative 10. And again, remember with WebAssign, you don't have to simplify. So you could be done right now, or you can combine like terms. Here is the negative 100x squared. And then cosine of 5x. And then the rest is subtracting this 10 and sine of 5x squared. We good?
You write the simplified version.
You can write the simplified version. Oh, you want me to? So, you're like asking for bonus points?
Yeah.
Like, okay, I got you. So to get bonus points, the simplified version would look pretty much exactly like what you see here. But all these dots would not be there. It'd just be negative 100 cosine of 5x squared. And then 100 x squared cosine of 5x squared. And then it'd be minus 10 sine of 5x squared. This would be pretty much the most simplified form. Okay? Alright, what was the other question? 15 and 16? Is that correct? I think. Let's see. So we recorded 12. Here we go, 15. So these are the ones that I'm talking about. And sometimes they can have cosine or sine and more stuff. So this would be probably written, I would probably write it like this, just for my peace of mind. Bless you. And then 4 plus that. So 4 plus all of that underneath 1 square root, 5 plus the next all of that underneath 1 square root, and then finally x to the power of 1/2. Common mistake. Can I multiply, these 3 powers to a power? No. Can you tell me why? Because there's a plus right there. That's why. And also because there's a plus right there. If it was multiplication, then you could all day. Okay? So, let's go ahead and take the derivative. The most outer shell is going to be 1/2 of all of this stuff to the negative 1/2. So it's just carbon copied. and then it's times the derivative of the cream. So when I multiply by the derivative of the cream, what's the derivative of 5? Or sorry, before that, what's the derivative of 4? 0. So now it's like you're looking at just this piece, and you're about to do chain rule, power rule, because that's the derivative of the cream, which is what?
1/2.
1/2 of that stuff to the negative 1/2. Do you agree? And then you'll multiply by that derivative in just a bit. So what goes in the parentheses? Yep, 5 plus x raised to the 1/2. Now you're going to multiply by the derivative of that. Yes?
So why don't you include the 4 plus as the stuff?
You do include 4 plus, but the thing is,
It just becomes 0 plus, right?
it just becomes 0. It's like two different equations. It's like doing two problems. This is a problem, and this is a problem.
Oh.
And this derivative is just 0, so really all we need to write down is that
Oh,
one.
okay. I see.
Okay? Alright, so it will be multiplied by what? By the derivative of this inside. Right? Which is
0 plus stuff.
0 plus
1/2.
1/2 x to the negative 1/2.
Wait, wouldn't it be x to the... Oh, no, my bad.
Okay? And then the last part is, I know you don't need it, but if I went in one more level, this is what we're learning today, and I multiplied by the derivative of the next cream, what would the derivative be? 1. Because ultimately what you're trying to do is you're trying to take the derivative of x in respect to x. We're going to learn what that means today. But it would be 1. Yes?
Another question. You put like the first bracket. Okay, so that's the second bracket.
So all of this, everything in the bracket is the derivative of the cream in here. Okay? And yes, if you wanted to, you could move this downstairs. And notice this. All of this business right here is multiplied. So let me do multiplication. Multiplication exists here. Multiplication exists here. Multiplication exists here. How many terms do I have? 1. Because it glues all of these pieces together. So what's in orange would end up being 1 over all of that. This 1/2 and this 1/2 and this 1/2 become what? 1/8. There's an understood 1 up there. Okay? And then, and I should have highlighted this all the way. Okay? And then you have this piece right here. It's going to be 5 plus the square root of x square rooted. That's there. And then the other one is x to the negative 1/2. Yeah.
Is it wrong if we leave it in the like?
Nope. It's totally correct if you leave it like this for WebAssign.
Okay.
Just make sure that you
Don't
get the
have
practice.
negative exponents?
That's what I was going to say. So just make sure that you get the practice of rewriting stuff, because on quizzes and tests, I will take off if you leave negative exponents.
No, what I meant was like, what if you change from the negative exponents? Do we have to put it back in radical form?
No.
Okay.
No, you can keep it as a fractional
Is
exponent.
that the one, the website answer, is that the most simplified answer?
Yep. Yep.
If you want bonus points, you have to do it.
I mean, even bonus points, you could do square roots, or like Danny was saying, you could do the parentheses with a fractional exponent, and it is still good. Good? All right, the last one is 16, and then we'll get to today's notes. Today's a big day. Today's a good day. All right, 16. 16 is a lot like 15. Okay, so it's going to be 3 of the stuff squared, and the stuff is all of this, times the derivative of the cream. So the derivative of the blue stuff is 0, right? Plus whatever the derivative of this chain rule piece would be. So you don't have to put 0 plus. I mean, you can if you want, but it's just more work that you're looking at. But this would be 4 of the stuff cubed. And that unchanged cream is that. But then we got to multiply by what? The derivative of the next cream, right? And what would that derivative be?
Why do you have to go? Because you took the derivative of the outside stuff, right?
Yeah, so right now what we're doing is this is the derivative of that.
Oh, so we haven't finished.
We haven't finished it
Alright,
yet.
Here's what you're saying.
You got to keep going as most as you can, because remember, the compositions, there's many levels. It could be f of g of h of I of x. Okay, so the last level that we will go is when we derive this cream, which is 2x. And again, how many terms do y'all see? 1. All of this is 1 term. So it's all glued with multiplication, and your 24x is right here. The x squared plus 5 raised to the 3rd power is right here. And then the rest is what you see. Alright guys, that is it for that.
And is that the most simplified version?
Yep, because there are no negative powers.
So.
Oh, as far as like the most simplified version, like for a test,
Yeah.
would look like this. I don't expect you to FOIL all that out.
Okay.
That's good enough. But I do expect you, look at it, the constant, then variables, and then like powers in ascending order, and then like natural logs, or, you know what I mean?
Wait, ascending order or descending?
It really doesn't matter. I'm not going to count off for that. And then just trigonometric functions after that in alphabetical order, please. All right.